This is on section 3.5, rational functions and their graphs. Next time is the midterm exam, so that's all we'll do that particular day. So. 'I haven't even looked to see where we are schedule-wise, if we're ahead or behind. Uh, 3.3, so a little bit ahead. Okay. Now, a rational function, rational means single fraction. Is there a row of tables coming? Okay. I'm not very observant. I'm sitting there, something's different. You guys are closer for some reason. First thing we're going to take a look at is how to find a domain of a rational function. And we've already seen this. This is where you have variables in the denominator. Step one, that the denominator equal to 0, and then solve, and then put a slash through the equals. Again, this gives us the value we cannot have. That's why we have to put a slash through the equals. So for our first problem here, got h of x is equal to x minus 5 over x squared minus 25. And going through these three steps, step one says set denominator equal to 0. So I got x squared minus 25 equal to 0. Step two says to solve this, and I'm going to solve it using the square root property because our middle term is missing. So I'll take negative 25 to the right side, becomes a positive 25. And square root property says if you got something squared equals something else, you drop your squared, and you put a plus or minus square root on the other side. Now, square root of 25 is 5. So these are the values we cannot have. So x cannot equal to negative 5, and x cannot equal to 5. Or if you write an interval notation and go from negative infinity to our smallest number, union our smallest number to our largest number, union our largest number to positive infinity. Infinite parentheses on everything. Let's take a look at another one of those. Got f of x equals x plus 3 over x squared plus 9. Same instructions. Oh, okay, it's downtown Wichita. Sounded like somebody's mother was coming into the room. Oh, that's up to you. I guess nobody's there in Wichita. Oh, Jeremiah's online. Okay. Okay, so step one, set your denominator equal to 0, then solve. Again, this is square root property because the middle term is missing. So I take 9 over, it becomes a negative 9. Square root property, we drop our squared, we put a plus or minus square root on the other side. Now square root of 9 is 3, and then the negative gives us an I. We saw this back when we covered domain before, is if you end up with an I, you cross that part off, because I's have no meaning in the real world. So our domain will be all real numbers. You could write it out in words like this, or you can write it negative infinity, positive infinity. Now this next topic is talking about limits. Limits means we study something as it gets closer and closer, not exactly at that value. For example, somebody's having some heart condition, and the heart rate, whatever, is increasing, and then right here is a heart attack, and then it comes off like this. Now we don't care from like a hospital standpoint. We don't care about this point. Because if we're studying at that point, it's too late. As I understand, a heart attack's not like a 2-hour event. By the time they get to your room, it's you're done with it. But this leading up to here, this can be a many hour event. That might be 8 hours leading up to it. And it's also important for us to be studying it from this side also. I have a friend that he went to work, Spirit, Hawker, Beechcraft, whatever it was called back then, and didn't feel right in the morning. And then as the morning went on, he just kept feeling worse and worse. He felt like maybe he was getting a flu or something, is what he said. And they were taking him to the ER about 3 o'clock via ambulance. And I'm not sure at what point he actually had his heart attack, but this right here is very important to be studied, because if you can study it at this point, notice something happening, you can give him medicine to stop the heart attack. So again, we don't care necessarily what's happening at that point. We're studying it as it gets closer and closer. A stroke. I took care of my father for 11 years, and one time we were sitting there watching a baseball game, and he said, I can't stand. And I said, what do you mean you can't stand? You're just standing just a minute ago. He says, I can't stand. He had had a stroke. If you told me a stroke lasts about 1 minute or 1 second, that wouldn't surprise me. It was that fast to when he couldn't stand anymore. And again, important studying it up to that point. That may be 20 years of bad diet, exercise, and all of those leading up to it. At that point, it's too late. Okay, that's the concept of limits. Now, first problem here, we got this notation here. This arrow here means approaches. This plus power means from the right-hand side. So we're wondering, as x approaches -3 from the right-hand side, what is f of x or y approaching or going to? Well, here's -3, and I'm coming from the right-hand side. You can think of this as tracing a graph. So if I'm tracing my graph, I'm coming along here. As I get closer and closer to -3, notice that my y value is going up forever. So this would be approaching, going to positive infinity. And that'd be our answer. Now, next problem here. This says as x approaches positive 1 from the right-hand side. Well, here's positive 1. I'm coming from the right-hand side, so I'm tracing my graph. Getting closer and closer to x equals 1. Y is, again, going up forever. Going up forever is positive infinity. Now this one says as x approaches positive infinity. And there is no plus power or minus power, which we'll see here in a minute, because you can only approach positive infinity from one side. Clear over here is positive infinity. So as as we're approaching positive infinity, let's examine what our y values are doing. Right here, y is equal to 3. Tracing. Right here, y is equal to 2. 1. Maybe a half. Maybe a third. 1/5. So on. So it's approaching 0. Now, all of this is to introduce a concept of what's known as an asymptote. An asymptote is an invisible line your graph will skim at some point. Now notice over here, it says we got a horizontal asymptote of y equals 0. This is why in this particular example, I know the graph doesn't go down below because that means my graph's going to skim the line y is equal to 0, which is our x-axis. Now, it may cross it at some place, like right here, it actually just crosses it, but at some place it's going to skim it. Over here, this is going to skim it over here. It'll get real close to it, but never touch it, never cross it. Now, these, what we saw in the previous two problems, we got vertical asymptotes. You can see this is going up, but even more than that, it's going to be skimming this line, never touching it, never crossing it. As this is going down, it'll be skimming this line, but never touching it and never crossing it. Okay, let's take a look at this problem. Now, what looked like the plus power was meant from the right-hand side. It's not really the plus power. What looks like the negative power is not really the negative power. This means from the left-hand side. So here's positive 1, and we're approaching it from left-hand side. So you're tracing your graph. And as we're approaching it from left-hand side, it's going down forever. So it's going to be negative infinity. Is there any questions on those limits? It's a calculus concept, but it's used to introduce what in the world's an asymptote. Now these next problems ask us to find a vertical asymptote. Finding the vertical asymptote. I'll put an S on there because you can have more than one. Step 1, back to the top, back to the bottom. Step 2, cancel if possible. Step 3, set the bottom equal to 0. And solve. Drink here. And let's take a look at this problem. Got g of x is equal to x minus 5 over x times x plus 5. Now I want to find the vertical asymptotes. Well, first step is factor the top, factor the bottom. They factor as much as they can be. Second step is to cancel if possible. They'd have to be exactly the same to cancel. If this is x plus 5, this should be an x plus 5. So I can't do that. Step 3, set your denominator equal to 0. So x times x plus 5 equal to 0. And solve it. So you get x equals 0, x plus 5 equals 0. So we've got 0 and negative 5. Those are my vertical asymptotes. I really don't know much about this graph, but I know at x equals 0, the graph's going to skim it at some point. We got a vertical asymptote. At negative 5. We'll have a vertical asymptote. It means our graph will skim this at some point. Now, we're not going to do a whole lot with these. It used to be when you did everything by hand, these were essential to understand how to graph these by hand. So we're going to be using a calculator. but we still need to know what an asymptote is for the tests and so forth. Let's take a look at number 8. G of x equal to x minus 4 over x minus 4, x minus 5. And find the vertical asymptotes. Step 1, back to the top, back to the bottom. They're factored as much as they can be. Step 2, cancel if possible. This time we can, because we've got an x minus 4 here, we've got an x minus 4 here. So those are going to cancel. So we're left with 1 over x minus 5. And then step 3, set your denominator equal to 0, set your bottom equal to 0, and solve. And that gives us x equals 5. And that's our vertical asymptote. Verticals up and down. We also have a horizontal asymptote. On some problems. And we've got 3 cases of this. Case 1, the degree of the top is larger. When the degree of the top is larger, there is no horizontal asymptote. Case 2, the degree of the bottom is larger. Your horizontal asymptote will be y equals 0. In case 3, degrees are the same, and I like to show this with an example. Very simple idea, but if I try to put into words and talk about leading term and leading coefficient and so forth, it just gets complicated. Degrees are the same. What I mean by that, degree is the largest power of x. The degree of the top is 2, the degree of the bottom is 2. The degrees are the same. What your horizontal asymptote is, you create a new fraction. And you take the coefficient, the number that's in front of the x to the largest power. So I'll take 4 here, put it up on top. I'll take a negative 3 here, put it on the bottom. And our horizontal asymptote would be y equals negative 4/3. So that's how you do those. Now number 9 here, the degree of the top is 1, the degree of the bottom is 2. So the degree of the bottom is larger. Degree of the bottom is larger, case 2, it says the horizontal asymptote is y equals 0. So that one will be y equals 0. For this one, the degree of the top is 2, the degree of the bottom is 2. So degrees are the same. That's case 3. We're going to create a new fraction, taking the number off the x to the largest power. So we're going to have y equals 8 over 4, or y is equal to 2. Number 11, degree of the top is 3, degree of the bottom is 2, so degree of the top is larger. That's case 1. Degree of the top is larger. It says we have no horizontal asymptote. So here the answer would be none. And one more. Find the horizontal asymptote of this one. Degree of the top is 1, degree of the bottom is 1, degrees are the same. That would be case 3. We create a new fraction by taking the number off the front of the x to the largest power. So we're going to have y is equal to negative 4 over 7. And that would be our horizontal asymptote. Questions on horizontal asymptote? Now these next problems go back to our shifts. Remember I told you the shifts will apply to all the different functions we'll see throughout the rest of the course. Now these describe our basic rational functions, 1 over x, 1 over x squared. Remember, if the number's at the very end, it shifts up or down, opposite what you think, or up or down. If the number's inside with the x, this time inside the denominator or inside the parentheses, it shifts left or right, opposite what you think. So here, the plus 3 is inside with the x. That's going to shift left or right, opposite what you think. So plus 3 would make us think right 3. So the answer here is left 3. Again, you don't have to graph these in the homework. It just says describe, you describe it. Now here I got a minus 3 at the end. That means down 3. Here I got a minus 4 inside with the x. Again, that shifts to left or right, opposite what you think. The minus 4, the negative 4 make us think left 4, so this is really right 4. So the answer here would be down 3, right 4. And one more. Now here we got a minus 2 at the end. That's going to move it down 2. Here we got a minus 1 or a negative 1 inside with the x. That makes us think left 1, so it's really going to be right 1. So down 2, right 1. Now to graph these. The key to graphing these let's see, number 16. Got 2x squared over x squared minus 4. The key to graphing these is if you have more than a single number or single variable on top or bottom, you have to put parentheses around that part. So when I plug these in my calculator, I need to put parentheses around top, parentheses around the bottom. Other than that, you just enter as you see it. Okay, so I got beginning parentheses, 2x squared, closing parentheses, divided by beginning parentheses, x squared minus 4. Then I press graph. And that'd be our answer. A couple things to note here is if I set my bottom part equal to 0 and solve it, I get x equals -2 and x equals +2. Those are vertical asymptotes at -2 and +2. Our graph's skimming them. If I think about horizontal asymptote, degree of the top is 2, degree of the bottom is 2, so degree is the same. I create a new fraction, y equals 2 over 1. The number's in front of my x to the largest power. So we get y is equal to 2 as our horizontal asymptote. So our graph skimming that at y is equal to 2. Let's go ahead and look at the graph of this one. Again, the key is put parentheses around top, parentheses around the bottom. So I'll have begin parentheses x minus 3, close parentheses, divided by beginning parentheses x squared minus 6x plus 8. And then graph. Now, if I were to find the asymptotes here, first off, the degree of the bottom is larger, which means y equals 0 is one of our asymptotes. So this appears just to stop, but I know it keeps going forever because it skims that, gets real close, but never touches, never crosses it. If I set the denominator equal to 0 and solve it, I get x minus 2 and x minus 4. So that'd be 2 and 4. And I see it has vertical asymptotes at 2 and 4. Questions on graphing those? Well, the last topic, I'm not going to graph these, but the last topic we're going to take a look at is finding something called a slant asymptote. Some books refer to this as oblique. So finding the slant asymptote. Again, you may have learned it under this name. What we do is we use long division and drop the remainder. Verticals up and down, horizontal side to side, slant is at an angle. X squared, 4x minus 7 over x minus 2. We have a note to have a slant asymptote. The degree of the top must be one larger than the bottom. So the degree of the top must be one larger than the bottom. As I look at this example here, the degree of the top is 2, degree of the bottom is 1. So the degree of the top is exactly one larger than the bottom. So we have a slant asymptote. I said we use long division. Remember, you take a look at the first term of each side, what goes up on top. You ask yourself, what times x gives you x squared? That'd be x. Whatever you put up on top, you multiply by what's on front. X times x is x squared. X times negative 2 is negative 2x. We're going to subtract that line, which means flip signs. So this becomes a negative. This becomes a positive. 4x plus 2x is 6x, and the x squared minus x squared drops away. Again, you look at the first term of each side, what goes up on top. I ask myself, what times x gives me 6x? And that'd be 6. 6 times x is 6x. 6 times negative 12, or 6 times negative 2 is negative 12. Subtract that line, we'll flip signs. So it becomes a negative, this becomes a positive. 6x minus 6x drops away. Negative 7 plus 12 is 5. But our step said to drop the remainder. So this would be our slant asymptote. It'd be y equals x plus 6. Number 19. Got f of x equals x to the third minus 2. Over x squared plus 3. Again, I want to use long division. So I got x squared plus 0x plus 3. And that's going into x to the third plus 0x squared plus 0x minus 2. Remember, we put it in standard form and we put 0 placeholders for any missing powers. Take a look at first term of each side, what goes up on top. You ask yourself what times x squared gives you x to the third, and that'd be x. X times x squared is x to the third. X times 0x is 0x squared. X times 3x gives us 3x. Or x times 3 gives us 3x. Subtract that, so we flip signs. X to the third minus x to the third drops away. 0x squared minus 0x squared drops away. 0x minus 3x is negative 3x. Bring it down to minus 2. Now this would be our remainder. It's a remainder because the degree of this is less than what we're dividing by. So this will be our slant asymptote. We have y is equal to whatever's on top, which is x. Questions on those? Midterm exam is Wednesday, 10/7. You can use 4 pages of notes front and back. But whatever you want them, I don't care. Do not use your cell phone. Use your cell phone. That's automatic that. So I'll remind everybody on class next time to shut off your cell phones and so forth. There's nice little web pages you can go to that you can type in everything on the midterm and it just tells you the answer. Obviously cell phones are taboo on a in-class math test. You have the hour and 20 minutes. So our normal class time to do it. And you have to come in for it. So if you've been attending virtually, or if you're attending virtually today, you can't do it at home. So it's not going to be done in my math lab. It's a paper test. So pass out papers and you'll do it there. Now, I want to leave the rest of the time for questions. So if you have questions, stick around and I'll answer those. 8.5 by 11. So you can put whatever you want on front and back. So yeah, I'm just gonna look to make sure you have 4 pieces of paper. So can't have 8 pages, one-sided, because I want it to be a visual. I just want to easily look at it and see what people have. Any other questions? Well, stick around if you have any other questions. I'm not going to go into another section. And the midterm will be next time.